Our second key strategy so that you can facilitate those 50 number sense warmups are number strings. And I'll be honest, these are a newer idea for me and I love them. I am absolutely obsessed with them. I do them in model lessons with kids all the time. I do them in my PD with teachers all the time. And I still feel like I'm learning a lot about how to do them well. So if you have any tips about how to facilitate number strings well, please drop them in the comments so that we can all learn from you as well. And let's get into exactly what a number string is and how to facilitate it with our kids. Number strings are also a great routine to value the different ways students think and reason about foundational skills. Because again, valuing the different ways students think and reason has been shown to decrease math anxiety. So we need to figure out a way to do this strategically and as much as possible so that we can start to decrease that math anxiety. And sometimes number strings are a great way to start off number talks, because sometimes, my students don't have all of the strategy ideas to get to a number talk, but instead a number string is a little bit more guided in terms of helping them make those connections and calling those connections out. So this is how you set up a problem string. There's going to be a number of different problems, and you're only going to show them like starting at the top, and then you're going to reveal the next, reveal the next, reveal the next. There's usually, I like to keep them to 4. You won't see more than 4 in the number strings with us. Some other people have 5 in them, or maybe 3, but I really like to stick to 4. So for example, your kids would walk in and this would be on the board. This would be their warm up, just seeing 6 plus 6. That's a pretty friendly way to walk in. Going to keep that amygdala low, going to keep that hyperactivity not there so that we can recall, retain, and problem solve. So we post only the first problem in the string and allow students to solve. You could have them talk to a partner if you felt like that was age appropriate, that would be challenging enough that they might want to double check. But then you could also just say, let's shout out the answer in 3, 2, 1. And then they would all say 12, and then call in a couple different kids. How did you know that 6 plus 6 was 12? Some of them might say, I have my doubles memorized. Maybe they know 6 plus 6, 5 plus 5, 7 plus 7. Maybe they counted on their fingers. Maybe they started at 1, 2, 3, 4, 5, 6, and then 7, 8, 9, 10, 11, 12. Maybe they started at 6 and counted on 7, 8, 9, 10, 11, 12, right? A lot of different ways. Maybe they know 5 and 5 is 10, 6 is 1 more, and there's 2 more that they need to add in. So that's 10 and 2. That gets me to 12. You want to hear some different strategies about how they know 6 and 6. But I have 6 plus 6 memorized is a perfectly good answer. But not every kid is going to have that memorized. So then what you want to ask them to do is you want to say, knowing that 6 plus 6 is 12, how can we think about this next problem in our string? And then you reveal that next problem, which is 7 plus 6, 6, 7, right? And that's totally dead, but it's still so fun for teachers because that was so chaos for so long. And ask them how their brain went from the first to the second problem in the string, and call in a few students to share their thinking. What we want them to see is we don't want them to start over at 7, 8, 9, 10, 11, 12, 13. We don't want them to do that. We want them to begin to see the patterns. We want them to build that number sense that I don't just always have to count up or count single digits. We want them to see that, well, if I know 6 plus 6 is 12 and I know 7 is 1 more than 6, then 7 plus 6 must be 1 more than 12, which is 13. Right. And so a student might not have that skill initially because that is fluency. That is a numerical fluency to be able to know and not just start from the beginning. We want to help them make a connection from one problem to the next in the string. Right. And so try to get a couple of different ways. How else could we see going from 6 plus 6 to now knowing 7 plus 6? How can I use 6 plus 6 to help me show 7 plus 6? And then you just keep showing them another string. Ask students again, knowing that 7 plus 6 is 13, how can we think about this next problem in our string? And then you reveal the next problem, which is 13 minus 6. This is helping solidify those fact families, right? So if 7 plus 6 is 13, then 13 minus 6 has to be 7. But again, we don't want a lot of students are going to be tempted to say 13, 12, 11, 10, 9, 8, 7. But we want to help them build that fluency. We want to help them build that, okay, if 7 plus 6 is 13, then 13 minus 6 must be the other number. That must be 7, right? Ask them how their brain went from the prior to the new problem in the string. Call in a few students to share out their thinking. How can we get there? You can still validate if a student counts on their fingers. There's nothing wrong with that. But we want to help them find new strategies, new creative ways to get through our problem string. And then you can reveal the last one, or however many more there are. And you're always asking, how can we think about this next problem in our string? Reveal that next problem. So if I knew that 13 minus 6 was 7, and I know that 14 is 1 more than 13, then 14 minus 6 must be 8. And ask them how their brain went from the prior problem in the string to the new problem in the string. Call in a few students to share their thinking, right? So they might do, because the goal is for them to start seeing the relationship between the numbers. And that's why I love problem strings, because it calls out those intentional relationships between the numbers. So yeah, any kid could do 14, 13, 12, 11, 10, 9, 8, and they could get there. But we want to help them reason with, okay, if I know that 13 minus 6 is 7, and I know 14 is 1 more than 13, then 14 minus 6 must be 1 more than 13 minus 6. That was 7, so this must be 8. And helping them build that fluency, helping them build that numerical understanding. And at the end of the string, they will have seen and heard multiple ways of thinking flexibly about that foundational skill, right? I'm not going to ever get my ninth graders to engage in a subtraction problem like that or an addition problem like that. But when it's in a problem string and we're focused on number sense and thinking flexibly and building that foundational flexibility with the numbers, it is suddenly more interesting to a 9th, 10th, or 11th grader, even a 12th grader who is struggling.